The square root method can also be solved equations that are in vertex form. So a quick reminder is vertex form is shown on your screen. So if you have a quadratic equation that looks something like this, x minus 4 squared plus 2, so this is just an equation because it's in one variable, that looks a lot like vertex form. You have a binomial raised to the second power. This is one that you can use the square root method on. So let's return to your note sheet and do a few examples. All right, I would like you to pause the video and try 4 on your own. Press play when you're ready to check your answer. So hopefully you started by subtracting 2x squared from each side, which gives me 2x squared minus 3 equals 4. Then add 3 to give me 2x squared equals 7. Now I'm going to divide by 2. Some of you might accidentally do your square root, but you want to get x squared all the way by itself before you do the square root to both sides. This gives me x squared equals 7 over 2. Please tell me you didn't type that in your calculator and see that it's 3.5. We always want fractions that are reduced in higher math. Okay, so now we take the square root of both sides, which gives me x equals, don't forget my plus or minus here, x equals plus or minus the square root of 7 over the square root of 2. Okay, so I just use my quotient rule and I split that 7 over 2 into the square root of 7 over the square root of 2. Now hopefully you remember that we cannot leave a square root in the denominator. So what do? We do that process of rationalizing the denominator, where we multiply by root 2 over root 2, which gives me, again, plus or minus the square root of 14 over square root of 2 times the square root of 2 would be the square root of 4, which is just 2. So here are my exact answers. And again, you can write that like this: x equals negative the root of 14 over 2, or x equals the positive root of 14 over 2. You can also get your approximate answer, because this would be our exact. So if you type that into your calculator, I get that x is approximately negative 1.87. That's to the nearest hundredth, or positive 1.87. So the second one is my approximate answer. Now 5 is the first one that's in a different form. So you notice that set of parentheses, and hopefully you're recognizing that that's awfully similar to vertex form, where you have that set of parentheses with your squared on the outside. So here's what we're going to do. We're going to try this time to isolate, here's how it's different, this x plus 3, because that's what's in parentheses there, raised to the second. So I need to get rid of the 1/5. So how do I do that? It's held by multiplication. The opposite is division. So I'm going to divide both sides by 1/5, which your calculator can do. So you'll see some kids write it like this, where they divide both sides by 1/5. Now, honestly, this is a big, ugly fraction then on that side. Calculator can totally handle that, but I just want to remind you that dividing by a fraction is the same as multiplying by the reciprocal. So it's better practice to show me that you're multiplying both sides by 5 over 1. Okay, multiply by 5 over 1. So 5 over 1 times 1/5 is 1, which leaves me with just x plus 3 to the second power over here equals 7 times 5 over 1 is 35. Now I have this x plus 3 to the second, so I need to get rid of this exponent of 2. How do I do that? Well, the opposite of squaring is to take the square root. So here's what I'm going to do. I'm going to draw the square root sign on both sides. The moment I do that, I'm going to put that plus or minus right out front of this 35. So that will make the exponent of 2 and the square root, they undo each other because they're inverses, and I have just the radicand, x plus 3 on the left, equals plus or minus root 35. And now I'll just check. Does 35 break down with a factor tree? That would be 5 and 7. I have no pairs, so it would just be plus or minus the square root of 35. Now I'm going to split this into 2 right away, because what this means is my one answer is x plus 3 equals negative square root of 35, or my other one is x plus 3 equals the positive square root of 35. Now I'm almost finished, but I don't quite have x isolated, so what am I going to do? I'm going to subtract 3 here on both sides. What's that give me? X equals, now how can I write this? 2 ways. I just always write, because the form of a complex number, I put the numeric integer first, negative 3 minus the square root of 35. There's my one answer. Or, over here, subtract 3 from both sides. Gives me x equals, again, I put the negative 3 first. There would be understood to be a positive in front of this, so plus root 35. Okay, now what I'm saying is you'll see some kids write this as negative root 35 minus 3. Same thing. It's just the first form that I wrote it in is, it's more standard in mathematics. Okay, so those are my 2 exact answers. Now what are my approximate answers? Well, you would have to type negative 3 minus root 35 into the calculator. And that gives me x is approximately negative 8.92, or, okay, so make sure you round right. I've got some of you that still struggle with rounding. I'd hate for you to do all this work and then, you get problems wrong just because you can't round appropriately to 2 decimal places. If you're still struggling with rounding, you really need to reach out to me, because it's such a simple concept that I think if I show you 1 or 2 examples, I'll clear up your confusion. All right, 2.92 would be the other. So those are your 2 places where your parabola crosses the x-axis. So again, this one's my exact, and this is my approximate. All right, so 6, give it a try if you think you can handle it. It's another one that's similar to vertex form, so that's how I know I can do the square root method. I'm going to begin by isolating the x plus 3 to the second. So I am going to get rid of this coefficient of 2 out front by dividing both sides by 2. That gives me x plus 3 to the second power on the left is equal to 8. Now I'm going to get rid of the squared by taking the square root. The moment I do that, I put plus or minus out front. That gives me x plus 3 on the left equals plus or minus the square root of 8. I know I can break down the square root of 8. That's going to be 4 and 2, 2, and 2. So I have 1 pair of 2's. That one comes on the outside. My leftover 2 here. Oops, I didn't mean to erase that. I meant to highlight it. That 2 stays under my square root sign. So this would be plus or minus 2 root 2. So this really means I have 2 problems going on here. I have x plus 3 equals the negative 2 root 2, or x plus 3 equals the positive 2 root 2. So what am I going to do? Final step, I need to get the x by itself by subtracting 3, which gives me x equals, now it's alone, I always put the integer first, the negative 3, minus, because of the negative sign, 2 root 2, or, again, subtract 3 from each side. X equals, this would be negative 3 plus 2 root 2. And they're not like terms, so don't you dare combine them. So here's my exact answer. Go ahead and toss it in the calculator and round to the nearest hundredth. So there's my 2 decimal answers. Let's look at an application question now. It says 2 joggers run 8 miles north and then 5 miles west. I'm a visual learner. I need to draw a picture. So 8 miles north and then 5 miles west. All right, 5 miles. What is the shortest distance to the nearest tenth of a mile they must travel to return to their starting point? So the shortest distance would be a straight line. So it's really saying, what is this side of my triangle over here? I'm just going to put the 8 on this side to make it a little clearer. All right, so I have a right triangle. Hopefully, you're remembering the Pythagorean theorem, which is used to solve missing sides of right triangles, where A and B are the two sides that make up the right angle. So if I substitute, this would be 5 squared plus 8 squared is equal to this unknown hypotenuse, c squared. 5 squared would be 25 plus 64 is equal to c squared, or 89 is equal to c squared. And what do? I take the square root of both sides. The moment I do that, I need plus or minus the square root of 89 is equal to c. Now, I'm going to actually, even though I said I need that plus or minus, I'm going to ignore the minus because I can't run a negative distance. So that's not really going to make sense in this context. So what am I going to do? I'm just going to get to the nearest tenth of a mile. So I'm going to do the square root of 89. So c is approximately 9.4 miles is what it would take to run back. So even though they've done 8 plus 5, 13 miles, it would only take 9.4 miles if they run a straight line back to their starting point. Let's look at an example where you get a complex answer. So this one is in vertex form. I'm going to start by getting rid of this 2 by dividing each side by 2, which results in x minus 3 squared equals negative 12. To get rid of this exponent of 2, I take the square root of each side, and the moment I do, I squeeze in the plus or minus in front of the square root sign so I don't forget that there are 2 solutions. This produces x minus 3 is equal to plus or minus the root of negative 12. So what I'm going to do is simplify negative 12 into negative 1 times 12. This right here will come out as I. 12 breaks into 6 times 2 and 2 times 3. So I have a pair of 2's, so it will come out as 2i, and the square root of 3 stays beneath the radical sign. Okay, so what I really have here is 2 answers, of course. So I'm going to break this into 2. One of them is x minus 3 equals 2i, the positive, 2i root 3, or x minus 3 is equal to the negative 2i root 3. Final step to isolate x would be to add 3 on both sides. This gives me x equals, I like to write the 3 first so that this is in standard form of a complex number. It would be plus, because it's a positive 2, 2i times the square root of 3, or over here, again, add 3 to both sides, produces x equals positive 3 minus 2i root 3. These are my 2 solutions. Now I will tell you, if you get a problem like this in Get More Math, again, since it involves a complex number, Get More Math has a non-real answer button that you would click. But what I have here is best.